In this lecture, let us discuss about distributional semantics, which is a fundamental concept in natural language processing based on the idea that meaning of a word can be inferred from the context in which it appears. And the core assumption is that words occurring in similar contexts tend to have similar meanings. This approach enables automatic learning of word meanings from large corpora of text. So, this is mainly formalized by distributional hypothesis, which asserts words that occur in similar contexts tend to have similar meanings. For example, the words cat and dog, they often appear in similar contexts. So, both might co-occur with words like pet, animal, tail, or fur, which suggests that they have similar meanings in certain contexts. And coming to contextual similarity, so words that appear in similar contexts, they are assumed to have similar meanings. Okay. So context is mainly defined as the surrounding words or phrases within a predefined window around a target word. So we saw this while discussing word to vec with the help of two models, skipgram and cbow. And if you take a sentence, the dog chased the ball, here the word dog, it is likely to appear in the context with the words like tail, bark, or fetch, which tells us that this dog refers to animal which is commonly associated with these terms like tail, bark, or fetch. Then word co-occurrence, words that frequently appear together, like king and queen with royal, they usually share meaning. And the co-occurrence matrix is a tool which is used to calculate this. Say if we have a word car in the corpus which appears frequently with the words like engine, drive, road, etc., then it suggests that these words are semantically related to this word car. And words with similar co-occurrence patterns, they are assumed to have related meanings. Then we have word vectors or word embeddings. These are vector representations of the words that capture semantic similarities based on context. And here, the words that are similar to each other, they are represented close to each other or close together in the vector space. These embeddings, they capture both the syntactic and semantic relationships between words. Popular methods for word embeddings are, first one is word to vec. In that we have skipgram and cbow. So skipgram, it trains a model to predict a word given its surrounding context, whereas cbow predict the surrounding context given a word. Then global vectors for word representation. So that this model factorizes the co-occurrence matrix to learn vector representation that preserve both local and global statistical relationships. And we have fast text, which is an extension of word to vec by considering subword information, which are n-grams, allowing it to handle out of vocabulary words in a better way. Vector arithmetic. Word embeddings allow for operations like addition, subtraction in order to explore the semantic relationship between words. So if you take example, king minus man plus women equal to queen. So this shows how distributional semantics can capture analogies, as the relationship between king and man is analogous to the relationship between women and queen. And dimensionality reduction. Co-occurrence matrices, they often have very high dimensions, which leads to sparsity. That means most of the entries in the matrix are zeros. Techniques like singular value decomposition are used to reduce the dimensionality of these matrices, creating more compact and efficient word representations. And modern advancements in distributional semantics include, the first one is contextualized word embeddings, which are transformer models. Traditional word embeddings, they usually assign single vector to each word without considering meaning in different contexts. Say if you take the word bank. So bank would have same embedding whether it means a financial institution or the side of a river. And contextualized embeddings like BERT. So that is bidirectional encoder representation from transformer, or even GPT, generative pre-trained transformer. So they generate different embeddings based on the context instead of generating same embedding for word in multiple contexts. So this actually resolves problems like polysemy. Polysemy means words with multiple meanings. So here in bird, so if you take the same example or the word bank, so it will have different embedding in first context and second context. So first context is I went to the bank to withdraw money. So here the word bank, it refers to financial institution. So embedding should be different. Whereas in the second case, refers to river bank. So in both the cases, BERT model, it provides different embedding for this word bank. Then pre-trained models. So if you take models like BERT, GPT and T5, they are trained on huge amount of text, and even it can generalize contextual representation of words, sentences or entire paragraphs. These models capture more meanings by considering the surrounding text, providing richer semantic representations than traditional distributional methods. Then applications of distributional semantics. First one is word similarity. By calculating the cosine similarity between word vectors, we can quantify how semantically similar two words are. So words with similar meanings like cat and dog, they'll have high similarity score. Then synonym detection. So words that share similar context will be identified as synonyms. For example, car and vehicle. So both of them will have similar embedding because they frequently appear in similar contexts. Then document classification. By representing words as vectors and then averaging or otherwise aggregating these vectors to represent documents, we can classify documents based on their content. So this is mainly useful in tasks like sentiment analysis, topic modeling and more. And machine translation. Distributional semantics, they mainly helps map words across different languages by analyzing how words co-occur in each language corpus. So this is the most important thing in models like word to vec based machine translation, which learns the mappings between word embeddings of different languages. And semantic analysis. So distributional semantics, they help capture sentiment behind words by examining their context in sentences. So if you take words like happy and joyful, so both of them appear in context with positive sentiment, whereas words like sad and angry appear in negative context. Then information retrieval and search engines. By representing both the queries and documents as word vectors, distributional semantics improve search engine accuracy. Words in a query are mapped to their nearest neighbors in the document space, helping retrieve relevant results.